In this screencast, we'll design a data definition to represent a list of integers. We'll follow our How to Design Data Definitions recipe. Let's get started with our data type definition as the first step in the recipe. In this case, we know we want to use a list, so we need to think about whether we need to create a name for this type, or if list event is sufficient. In this case, I think list event sufficiently describes the type, so we'll use that. We also have to remember to import the list type. Since we don't need to give our new list type a name, we'll comment out our data type definition. The next step is to write the interpretation. The interpretation for a list type is straightforward. We can always say it's a list of X, where in this case, X is integer. So, a list of integers. Now we need to write some examples that demonstrate how to form data of this type. I'll write a couple of examples. It's always useful to include the empty list as one of the examples, so that we don't forget that an empty list is a valid list of integers. I'll write another example with a number of different integers, including both positive and negative integers. Now it's time to create a template for a one-argument function that takes data of this type. We are not designing a function at this point. Instead, we are creating a template that we'll use in function designs in the future. Every time we design a one-argument function that takes a list of integers, we'll use this template. I'll start to write the template with def fun for LOI, using LOI as an abbreviation for list of integer. It's a one-argument function that takes a list of integers, and since it's a template, we don't know what the return type will be. So we use ... and that will be filled in when we use this template to design a function. To determine what to put in the body of this template, I'm going to open the DataDriven Templates page and scroll down until I get to the row for arbitrary-sized. I see it says that I need a for loop to iterate through the list and optionally an accumulator. I'll include the accumulator in the template, and I would delete it in a function design if I found that I didn't need it. I will copy the body of the template and paste it in, and then make updates as need be. On the DataDriven Templates page, this variable was named X because it was intended to be generic. Because I know I'm looping through a list of integers, I'll change it to I. And I'll change X to I here where I'm accessing the value stored in the variable. Now I need to write down the template rules that I used. If I go back to the DataDriven Templates page, I can see that I used the arbitrary size rule. So I'll write template based on arbitrary-sized. Finally, I'll run the code to make sure that there are no syntax errors.